Welcome to Data Dog. I am Data and I am your dog. Let's learn about central tendencies. Now, what do I mean when I say that? Well, I'm mostly talking about quick descriptions to summarize data, as if I was explaining it to someone else. Now, a shoe company might do a research study to find out the average shoe size so they know how to make their shoes. A study might conclude that the average size of men's shoes is 10, so they would know to make the most of those. It doesn't mean that the only size is 10, but it's the most accurate way to make a quick statement about a group. There are different methods of central tendencies, and they all bring their own strengths depending on the way that it's used. Now let's look at a sample of numbers and say that each number within the sample represents a shoe size. The numbers that we have are 20, 7, 5, 10, and 9. First, we'll look at the median. Now, the median is the middle number. We can't just choose the middle number. You have to sort it first, from smallest to largest. If we don't, we could very possibly get the wrong number. I like to do this for any sort of data that I have, even if I'm not trying to find the median, because it can help me find patterns before I even analyze it. After sorting the sample, the numbers that we have are 5, 7, 9, 10, and 20. That looks so much better. Now we can find the median. An easy way to do this is to remove one number on each side until we are left with the middle number. After doing this one by one until there's one number left, we can find that the middle number is 9. Thus, 9 is the median. Easy, right? We have 5 numbers in the sample, but what happens if we have an even number? How about 3? So the sample of numbers we have is now 20, 7, 5, 10, 9, and 3. First, let's sort out the numbers. 3, 5, 7, 9, 10, and 20. So we're going to find the median the same way that we did before. But we can only do this so much until there are only 2 numbers left in the middle. We have 7 and 9. Okay, well, what happens now? We find the average. This is also known as the mean. Feel free to call it the mean or the average. They're used interchangeably. To find the mean, we add up those 2 numbers. 7 plus 9 equals 16, and then we divide by the amount of numbers that we've added together. So, 16 divided by 2 is 8. 8 is our median. Our next central tendency is mean, something that we just went over. Again, when it comes to the mean, also known as the average, all we do is add up these numbers and divide that big number by the amount of numbers that we use to calculate that number. So, 3 plus 5 plus 7 plus 9 plus 10 plus 20 is 54. So, we have 6 numbers. So we divide 54 divided by 6. 9 is our mean. Lastly, we have the mode. I like to remember mode by the first 2 letters, M-O. Another word that begins with M-O is most. So, which number appears the most? All you have to do is count each value and see what appears most often. If multiple numbers have the same count, you have multiple modes. However, if there are no duplicate numbers in your dataset, you have no mode. In this case, each value only appears once, so there is no mode. Now that we went over the 3 main types, what's the most appropriate here? Well, let's think about the measurements of data. If you hadn't seen it, a link to the video will be tagged so you can get a deep dive in there. But for now, we will talk about which central tendency method is the most appropriate for the data measurement tool. Nominal data, as I've explained in the last video, only allows for counting. Imagine our presidential elections, for example. Do we factor in finding the average vote or the median vote? No, how could we? Voting for one candidate or another has no mathematical value. We do, however, take into consideration how many votes are for candidate A or candidate B. Therefore, we use mode for nominal data. How about ordinal data? Because ordinal data doesn't have equal spacing, we can't find the average. And while we could find the mode, it would completely ignore the non-popular votes. In order to take all values into consideration, we use the median. Let's say we poll 100 kids how much they love trampoline parks on a scale from 1 to 10. In order to ensure that all of their voices matter, we find the middle number. interval data gives us a little bit more freedom. You can use either mean or median, although the latter, median, appears to be a little bit more favored. The reason why is that interval data is much more susceptible to outlier data than ratio. Also, just in case you didn't know, in data science, an outlier is a point of data that is far, far removed from the rest of the other data sources. For example, let's go back to our shoe sizes. Do you notice something about the 20 and the 3? All of the other data points are hovering around 8 or 9, our median and our mean. However, the 3 and the 20 are far away from the rest of the other numbers. Because they are so far away from the other numbers, we consider them outlier data. Now back to our original example. If we were capturing the temperature of the Earth throughout all of history, the mean would be thrown off by the highs from when it first formed and the lows from the Ice Age. By capturing the median, we can find much more representative temperatures to describe how our normal everyday temperatures are. Lastly, we have ratio data. For most topics, we use mean. Unlike interval data, we have true zeros and we can use this information to our benefit. Imagine if an alien came to Earth and instead of wanting to overthrow humanity, they just wanted to know how old everyone was. We could just ask a group of people and give them that information. As you can imagine, compared to the temperature scenario of interval data, there are fewer outliers. It's easy to imagine the world at one point being 1,000 degrees, a lot more so than imagining someone was 1,000 years old. There are, however, a few examples where we don't use mean when it comes to ratio data. There are people in the world who make close to nothing, and then there are a few people in the world who make billions of dollars a year. Because of that, the outlier data can throw off our numbers. For cases like this, we would resort to median data. You should feel proud of yourself. We've learned about central tendency and how we use different scales of measurements to determine how we choose the right approach. Stick around as we explore the wonders of data together here on Dawg. Don't forget to join our pack by pawing that like button, hitting that notification icon so you won't miss a future video, subscribing, leaving a comment, and sharing this video with the rest of your pups. So until next time, stay curious, stay analytical. Peace out, dogs.